Hello everyone, this is Mr. Mahmoud Hussein from Al-Noor International School. Grade 10 Algebra teacher. Welcome to week 12, chapter 13, lesson 3, radian measure. The objectives of the lessons are here. Convert angle measures between degrees and radians. Find the values of trigonometric functions on the unit circle. What is a radian measure of an angle? A radian is a unit of angle measure based on an arc length. Recall from geometry that an arc is an unbroken part of a circle. If the central angle theta in the circle of a radius r, then the measure of theta is defined as 1 radian. Look at these figures. As you can see from these figures, the angle theta at the center of this circle with radius r, and it subtends the arc length r. So theta is 1 radian or 1 rad. From this figure, the central angle is 1 radian and its radius is 1, and it is arc which is subtends the central angle is 1 radian. Let's see some important facts about conversion factors. An angle with full rotation measures 360 degrees, which is the same as 2 pi radians. In fact, the circumference of a circle is 2 pi r. So if the radius of a circle were 1 unit, then a circle would contain 2 pi radians, which means 2 pi times 1 will give you 2 pi radians. This gives us our conversion factors. 360 is equals to 2 pi radians. Notice that dividing both sides by 2 gives 180 degrees, which is equals to pi. How do you obtain this? Just by dividing by 2 and by 2. This will be 180 and this will be pi radians. In general, 1 revolution is equals to 1 times 2 pi radians, which is equals to 2 pi, which is equals to 360 pi. What about 3 over 4 revolution? It's 3 over 4 times 2 pi, which is equals to 3 pi over 2 radians or 270 degrees. 1 over 2 revolution or half revolution equals 1 over 2 times 2 pi, which is equals to pi radians, and is equal to 180 degrees. 1 over 4 revolution would be the same as 1 over 4 times 2 pi, which is equals to 2 pi over 2 radians, which is equal to 90 degrees. 3.5 revolution equals 2.5 times 2 pi, which is equals to 5 pi radians or 900 degrees. Let's see some relationship between the degree measure and radian measure of special angles. As you can see from this figure, 0 degree is the same as 2 pi radian or 360, because 1 complete revolution will end here. 30 degree is the same as pi over 6 radian, which is an acute angle. 45 degrees pi over 4 radian, 60 degrees pi over 3, 90 degrees pi over 2 radian, 2 pi over 3 radian is the same as 120 degree, and so on. And 180 degrees pi radian, and so on. 270 degrees 3 pi over 2. Now let's see some key concepts of the lesson. To convert degrees to radian, multiply by pi over 180 degree. To convert radian to degrees, multiply by 180 degree over pi. And from the previous or above slides, you learned that pi radian is equals to 180 and 1 radian is equals to 180 over pi. So keep these factors or conversion factors in your mind, because it's very important to use them when you want to convert from one unit to another one. Example number 1. What is the radian measure of an angle of 72 degree. So we are going to convert 72 degree into radian measure. So which conversion factor are you going to use? It is pi over 180. Theta times pi over 180 degrees equals to, since theta is 72 degree, so 72 times pi over 180 degree. You can simplify these numbers. What is the greatest common factor of 72 and 180? Of course it is 36. So by 36, this is 2, and by 36, this is 5. So your answer will be 2 pi over 5 in the simplest form. Example number 1, part B. What is the radian measure of an angle of negative 3 pi over 5? As you can see, the angle is given radian measure, so we need to convert it into degree measure. And our conversion unit will be 180 over pi. Theta is negative 3 pi over 5, so times 180 degree over pi, which is the same as negative 3 pi over 5 times 180 over pi. So you can simplify by crossing out pi by pi, and 180 degree by 5 will give you negative 180 degree. Example number 2, finding cosine and sine of radian measure. What is the exact value of sine pi over 6? So, as you can see from this triangle, it is 30, 60, 90 triangle. And then we know the fact that the shorter leg is x, so the other longer leg is x root 3, and the hypotenuse is 2x. But what do we know about pi over 6? Why we need to have this triangle here? Because in the previous slides you have seen that pi over 6 radian is the same as 30 degree. So it's very important to use the relationship between the 30, 60, 90 triangle. Since sine pi over 6 is the same as sine of 30 degree, which is equals to opposite over hypotenuse. Here is angle 30, so the opposite is x and the hypotenuse 2x. So you can simplify by crossing out x by x, you will get 1 over 2. What if you are asked to find the cos of 60? Cos of 60 will be still adjacent over hypotenuse. Will have the same answer with sine of pi over 6. Now let's see the relationship between the arc length, radius and central angle. For a circle of radius r and the central angle measures theta, the length s, which means the arc length s of an intercepted arc is s is equal to r times theta. The angle theta must be a radian measure. As you can see from this figure, theta is the central angle and r is the radius of the circle, and s is arc length, which subtends the central angle theta. So s is equals to r times theta, where theta is in radian measure. Or if you want to find radius in terms of s and theta, r is equals to s over theta, and theta is equals to s over r. Example number 3, finding the length of an arc. How do you find the length of the arc to the nearest tenth of a circle of radius 6.8 units in that subtends a central angle of 8 pi? The central angle is 8 pi, and the radius of the circle is 6.8. So we know our formula. The arc length S is equal to radius times central angle theta. So S is equal to 6.8 times 8 pi, which is radius, which is equal to 6.8 times 8 times 3.14. Approximately pi is 3.14, which gives you 170.816. So to the nearest tens, it will be 171 units. Example number 4 is about how to apply this concept in our daily life using a radian to solve a problem. With the satellite at a distance of 3,000 km above the Earth in a circular orbit around Earth, where the radius of Earth is 6,400 km, completes one orbit every 2 hours. How far does the satellite travel in 1 hour? Assume this is the situation. If this circle models Earth and this models the orbit of the satellite, and this is the distance above the Earth, and this is the radius of the Earth. This is the same as this one, of course, the distance above the Earth at which the satellite is located. So how can you find the angle, the central angle that subtends this arc? If the satellite completes one revolution in 2 hours, which means 2 hours equals to pi radians, so 1 hour will be pi radian by dividing by 2 both sides. So the arc length of this circle will be S is equal to R times theta. Here R is the distance at which the satellite located, which means it is the sum of the radius of the Earth and the distance above the Earth, which means this one. R is this one. So R is equal to 6,400 plus 3,000, which is equal to 9,400 km. Substituting this value in this formula, S is equal to 9,400 times pi, which is equal to 9,400 pi, or 9,400 times 3.14, because pi is 3.14 approximately, is about 29,516 km in hour. Finally, dear students, don't forget to practice on exercise from your textbook and the workbook related to this lesson. Thank you.